Okay, hello everyone. We'll talk about relative humidity. Relative humidity is the ratio of the mass of water vapor present to that which could be present if the air was saturated at the same temperature expressed in percentage. Okay, so relative humidity is expressed in percentage. Now, the changes in relative humidity are not achieved solely by the decrease or increase of air temperature. Saturation can result from an increase in water vapor content or by a simultaneous increase of vapor content and decrease of air temperature. So now, how can we obtain the relative humidity? Now we have the relative humidity table. So part of the tables, first we have the tables or axis of the dry bulb the temperature. And we have here the difference of wet bulb and dry bulb temperature, or what we call depression. Okay, depression of the wet bulb and dry bulb thermometer, or the difference between those two readings. So for example, we have the dry bulb of 20 degrees Celsius and the wet bulb reading of 15 degrees Celsius. Okay, so the depression or the difference is 5 degrees Celsius. Okay, because 20 minus 15 is 5. Now we will have, or we will obtain the relative humidity. So let's enter the table. Dry bulb having the 20 degrees Celsius, and the difference or the depression of the dry bulb, which is 5. So go down to the table. In line with 20 degrees, we will have 58%. So relative humidity is 58%. Okay, 58%. Okay, how about dew point? Okay, so we have the dew point, or dew point temperature is the temperature by which a sample of air must be lowered in order to saturate it with respect to a plain liquid water surface. Okay, so dew point, or point of temperature wherein we can expect the presence of dew or the presence of fog. Okay, so how to determine or how to obtain the dew point temperature? We have the dew point table. So by using the same given, dry bulb is 20 degrees Celsius, wet bulb 15 degrees Celsius, equals to the depression of 5 degrees Celsius. Let's take note, the relative humidity is at 58 degrees Celsius. So let's enter the table. 20 degrees Celsius for the dry bulb reading. Depression, 5. As per the table, we have 12 degrees Celsius. Dew point, 12 degrees Celsius. Okay? So with this, we can have this dew point of 12 degrees. We can say that, for example, you will approach the area of from 20 degrees down to 15, 14, and by 12, we can expect that we will have a dew or a fog. Okay, so just to be clear, air is saturated is the state of atmosphere in which air contains the maximum amount of water vapor that it can hold at a specific temperature and air pressure. So at saturation, the relative humidity is 100%. The temperature and dew point are equal and evaporation of water ceases. Thus, fog occurs. Okay, so let's test that condition. For example, we have 10 as the dry bulb reading, and the wet bulb reading is also 10 degrees, and we have 0 as the depression. So we can have the relative humidity as 100%. For the presence of the dew point, same, dry bulb is 10, wet bulb is also 10, depression is 0, then our dew point is 10 degrees Celsius. So air is saturated, we have the dew, and we will expect fog.